Even though Elon Musk is quite busy because of the addition of Twitter to his portfolio of businesses, the true nerd is that he still finds time to pursue his passion for spaceflight. The billionaire, who has been a fervent supporter of the Voyager spacecraft, recently learned of a startling finding made by the two spacecraft. One of the twin Voyagers discovered this time, how long would they be able to maintain themselves in the void of space? Elon Musk was a scrawny 6-year-old boy when NASA launched the two Voyager aircraft. But as an adult, Musk and the Voyagers have a lot in common. For instance, Moscow uses Cape Canaveral in Florida, where their renowned Voyager spacecraft were launched to launch rockets for commercial purposes. Incredibly, the two spacecraft are still operating in space after 50 years, despite his Musk's advanced age. At the time of the mission's launch, few people could have predicted that it would persist for many years. The 4-year mission was plenty for the planners, but because of these tenacious spacecraft, we are still discovering new facts about the distant universe. Although it may not be widely known, the Voyagers would not have been launched if the stars had not physically lined up. In this instance, the stars were Jupiter, Saturn, Uranus, and Neptune, the 4 largest planets in our solar system. The last time this happened was in the early 19th century during Thomas Jefferson's presidency. The alignment of the 4 planets meant that each major planet's gravitational pull would give the spaceship a boost in speed as it passed. The spacecraft appears to be pulled along by an invisible cord that abruptly snapped, sending the probe hurtling on its merry way. And NASA scientists calculated that the repeated gravity assist would massively cut the flight time between Earth and Neptune from 30 to 12 years. There was just one catch. The alignment happened only once every 176 years. So to ensure the spacecraft reached the planets while the lineup lasted, a spacecraft would have to be launched by the mid-1970s, which is precisely what NASA did. To fully capitalize on this once-in-a-lifetime chance, NASA constructed not one, but 2 identical spacecraft, each roughly the size of a vintage Volkswagen Beetle and capable of carrying out all the functions required of the spacecraft. A portion of the onboard intelligence caused NASA to abandon the Voyagers. This was a computer with 69 kilobytes of memory, or less than 100,000 times a typical smartphone's memory. It is not even proper to compare it to a smartphone when a key fob used to open the car door has more memory. All the data collected by the spacecraft instruments would be stored on 8-track tape recorders and then sent back to Earth by a 23-watt transmitter, about the power level of a refrigerator light bulb. To compensate for the weak transmitter, both Voyagers carry 12-foot wide dish antennas to send and receive signals. The Voyagers have made numerous discoveries since their launch in 1977, but what has helped them keep functioning till now? Voyager 1 now holds the record for the most distant artificial object from Earth. Billions of miles away in interstellar space, it takes about 2 days to receive signals from the spacecraft. It is now in one of the harshest locations in the universe, with extremely cold temperatures and pitch black darkness. It also contains an extremely high amount of radiation. As such, not only do the scientific instruments on board need power, but the spacecraft also needs to keep itself warm in the frigid environment of space. Solar power is useless here because the sun's rays do not reach these spacecraft at their location. Instead, they rely on radioisotope thermoelectric generators, or RTGS, for their energy. Each of the Voyager probes carries these RTGS. They use plutonium-238 as a fuel source. When the isotope decays, heat is produced and converted into electrical energy. Each Voyager launches with 470 watts at 30 volts DC. But the problem is that it degrades over time. However, that is only one of the few workable solutions that could power the spacecraft for decades. Voyager 1 arrived at Jupiter in March 1979, after 546 days of travel. Voyager 2 launched some days after Voyager 1 and was set on a different trajectory. It arrived in July of that year. Both spacecraft were designed to be stable platforms for their Vidicon cameras, which use red, green, and blue filters to produce full-color images. The Voyager spacecraft don't spend much while traveling through space. Its rotational motion is more than 15 times slower than the crawl of a clock's hour hand. This is a deliberate design decision to minimize the risk of blurred images. Voyager 1 started transmitting pictures of Jupiter while it was still about 3 or 4 months away from the planet, and they were unprecedented in quality and detail. The pictures of Jupiter's moon shocked scientists because its colorful appearance was completely unexpected. Before the advent of the Voyagers, the assumption was that all of the solar system's moons would be more or less alike. The Earth's moon drab and craggy. No one anticipated the wild diversity of moonscapes the Voyagers would discover around Jupiter and Saturn. The Voyagers were powerful, at least for the period they were constructed well more than 1 million miles away from Jupiter. One of their instruments, the Low-Energy Charged Particle LECP detector system, picked up what scientists thought were unusual signals. They began noticing oxygen and sulfur ions hitting the detector. The density of oxygen and sulfur ions had shot up by 3 orders of magnitude compared with the levels measured up to that point. At first, the team thought the instrument had malfunctioned. Still, on further scrutiny, they realized there was nothing wrong, and thanks to the Voyager cameras, scientists solved one puzzle of whether Io had active volcanoes. The moon slightly bigger than the Earth's moon was confirmed to be the most volcanically active body in the solar system. Before that time, the only active volcanoes we knew of were on Earth, but Io had 10 times as much volcanic activity as Earth. Io's colors and the strange ions hitting Cremagi's detector came from an element blasted from the moon's volcanoes. The largest of Io's volcanoes, Pele, blows out plumes 30 times the height of Mount Everest. Debris from Pele covers an area about the size of France. The cameras on the Voyagers took more than 33,000 images of Jupiter and its satellite alone, most of them presenting never-before-known information. For instance, Jupiter had rings Europa, one of Jupiter's 53 named moons, covered with a cracked icy crust now estimated to be more than 60 miles thick. The two Voyagers separated at Saturn, with Voyager 1 hurtling through Saturn's rings and flying past Titan. It then turned north out of the plane of the planet. Voyager 2 then proceeded to Uranus and Neptune, spotted 10 new moons around Uranus and added the planet to the growing list of ring worlds. However, these discoveries were overshadowed by the tragedy of the Space Shuttle Challenger exploding shortly after launch. All 7 Challenger crew members were killed, including Krista McAuliffe, a high school teacher from New Hampshire who was built to be the first civilian to travel into space. Voyager 2 would reach 2,980 miles above Neptune 3 years later, where it measured the fastest wind ever recorded in the solar system. 1,000 miles per hour. It also confirmed one of the coldest places in the solar system, Neptune's largest moon, Triton, with a surface temperature that could drop as low as minus 235 degrees Celsius. Ice volcanoes spewed nitrogen gas and powdery particles 5 miles into their hemispheres. Voyager 1 is responsible for one of the most iconic photos of the Earth, and that would not have happened without the insistence of famed astronomer Carl Sagan. What happened was that after the images of Neptune and its moons, NASA was ready to turn off the cameras on both probes, although the mission had been extended in the hope that the Voyagers would make it to the interstellar space. They had decided there would be no photos after Neptune because after the planet, there was only the endless void and impossibly distant stars all around. However, Sagan pleaded with NASA to make Voyager 1 send one last batch of photos, and thanks to his influence, the spacecraft aimed its camera back toward the Earth on Valentine's Day of 1990 and took 60 final shots. The most moving of them was the one dubbed the Pale Blue Dot. It captured the Earth from a distance of 3.8 billion miles, and that picture remains the most distant portrait of our planet ever taken. Veiled by one ray of sunlight reflected of the camera's optics, Earth is barely visible in the image because the planet doesn't even occupy a full pixel. The Voyagers are still in contact with the control center, but they receive between 3 and 4 light seconds every day. Scientists connected them using NASA's Deep Space Network, which consists of 3 tracking complexes located around the Earth. Both Voyagers have now crossed heliopause as they continued their journey out of the solar system. Voyager 1 crossed the Atlantic in August 2012, while its twin did so more than 6 years later. However, the two spacecraft can still pull surprises on their handlers. For example, earlier this year, NASA detected Voyager 1 had been sending back mysterious data. The probe's Attitude Articulation and Control System, or AACS, manages attitude movements, high-gain antenna alignment, and spacecraft orientation. Scientists from NASA are not even certain that the data is not random now that the AACS have sent back information that they claim does not mirror what is happening aboard Voyager. NASA asserts that the Voyager 1 is still functional for the most part despite its advanced age. As a result, a team in charge of the spacecraft is keeping a tight eye on the signals to identify whether the erroneous data originated from the AACS or from some other system that generates and transmits telemetry data. A software update can resolve the issue. The Voyagers have encountered difficulties previously. The engineers quickly switched to other thrusters in Voyager 1 that were operational during the mission's planetary encounters some 37 years ago in 2017, when Voyager 1's primary thrusters started to show signs of aging. Amazingly, the second set of thrusters perform without a hitch. It illustrates the Voyager spacecraft's outstanding durability and clever design. With some operations being turned off to extend the power source, Voyager 2 now only has 5 operational instruments. Voyager 1 has had it worse as only 4 instruments are functioning. Nevertheless, NASA shut off the heater for the cosmic ray detector, which helped establish when it passed the heliopause. The magnetometer and the plasma science instrument will likely be the final 2 Voyager equipment that NASA turns off. They are safe inside the spacecraft's body, where the heat produced by the computers will still provide some warmth. The Voyagers still move through space even after all their instruments have been turned off. They may even travel to Proxima Centauri, our nearest star, in roughly 16,700 years, where they will stay for a very long time after we are gone. That is our video for today. We hope you like it. Share all of your thoughts with us in the comment section below. Well, that's all for now. This is Big Tech Media. See you again tomorrow. Keep in mind to like, share, and subscribe.